But many people remember me for bringing the moon rock samples here. I always like to say when we have visited that ASU got over 200 lunar samples before any of the other schools in the state got any. And then when they announced the opportunity to do analyses of the moon rocks, then I just followed that up. So essentially, we practiced on the meteorites. And in fact, we haven't talked about that yet at ASU. One of the obligations that the NSF put is that we must provide samples to all the scientists in the country and around the world to keep this as a research collection. So we were sending out lots of samples for analysis. And most of those analyses at the time were to see how the solar system was formed and things like that and understand meteorites. But it also was practicing for the moon rock samples. So I had, in fact, my first paper from ASU, research done here, not at Caltech or in Connecticut, was analysis of carbon in meteorites. And we developed a very nice technique that worked. And my motto is, the only good analytical chemist is a frightened one. You have to keep trying to make sure you're not making a mistake and going on. So when I applied to NASA, then because I'd done the carbon analysis on meteorites, they said I would be the one to do it on the moon rocks. I of course remember when they went to the moon, and the place I held my breath when it was time for them to take off and come back. And they did.
Did you have any say in what rocks they picked up?
Oh, no. I think the first two missions, 11 and 12, were political, mechanical missions. They landed near the equator of the moon where it's easier to land. They picked up rocks randomly, although they had been trained in the geology of what to look at. But I think the important thing was to land, pick up something, get out of there. And they brought in. And the first sample that we got here at ASU was lunar soil, or properly called regolith, where they just took a scoop and scooped up some of the surface and brought it back to the lunar receiving lab. I went to Houston to pick it up. The first analysis, I of course remember the date, was in the evening of October 9th, 1969. And we put the sample in our instrument, which requires that the sample be burned. And then the carbon turned into carbon dioxide, which we detect with a gas chromatograph. And the wonderful thing is, it was a dial, like the dial on a clock. And we pushed the buttons and waited, and all of a sudden that clock started moving, and we had carbon in the sample. And it had about 120 parts per million carbon in the moon rock. Then we got the other types of moon rocks, chips broken off of the larger rocks the astronauts brought back. And we'd get about 2 or 3 grams, which are little pieces about 1/4 of an inch in size, but we can do our analysis with those samples. I got a hurry-up call just before Apollo 12, and these missions went on one right after the other, and said, can you come now to Houston and set up a parallel instrument to do the analysis in Houston? So starting with Apollo 12, not only was I on the lunar sample analysis team, I was on what they call the lunar sample preliminary examination team in the quarantine labs in Houston. And I was one of the 5 or 6 scientists that got the moon rocks first. And we were in the same place where the astronauts were kept to make sure there was no diseases or things brought back from the moon. We had to sign a form which said, if there's a break, we're in there. If it's bad, we may be in there the rest of our life, but it's worth doing. For Apollo 12, and we were all set up for Apollo 13, and then of course it had the accident and didn't go. And Apollo 14, we did this, and by then they knew that there were no bugs on the moon, so they relaxed it a little bit. We still did the preliminary examination, but we didn't have to go through the whole quarantine thing. So I had a lot of nice graduate students at the time, and they worked on meteorites, and they worked on the moon rocks, and we just juggled the teaching and juggled the research all at the same time.